Right. So what is this? Magnetic resultant magnetic induction due to magnetic poles. Hmm? It's the three cases. Let's see the three cases. The first case is yeah, the first case is if two magnetic poles each of strength m are placed at the two corners of an equilateral triangle. Let us write this the conditions also. Two like magnetic poles into like magnetic poles of strength m of strength m are placed at the two corners of equilateral triangle are placed at two corners of two corners of an equilateral triangle equilateral equilateral triangle of side A of side A, then the resultant magnetic induction at the third corner is then the resultant magnetic induction at the third corner the third corner is. So we have to consider the pictorial representation like this. So there is a equilateral triangle, right? So you can take the shape of a triangle. So this is the equilateral triangle. Okay. So it is given that there are two like poles of magnetic strength m. So like poles means of same sign plus m, like charges plus q here magnetic electric charges, here we can call them as magnetic charges. Pole strength is nothing but magnetic charge. Pole strength can also be called as magnetic charge. So it is given that two like poles of magnetic strength m are placed at two corners. Then after equilateral triangles of side A, means equilateral triangle means all sides will be having a same length, and angle between each side will be equal to 60 60 60. Then what is the magnetic field at the other corner, the third corner? This is the third corner. Here what is the magnetic field? So it's just like electric field case. Whenever you are asked to find electric field at a point, at that point you have to keep unit positive test charge. Same way here you have to keep unit positive north pole. Unit north pole you have to consider. North pole will be usually positive pole. So unit what do you call, you have to keep unit north pole. Unit north pole means so plus 1, m should be equal to plus 1. Pole strength of this is the pole strength of north pole, it is equal to plus 1. Then actually you have to find the magnetic field here due to this and due to this, and then you have to add them vectorially. So magnetic field by definition is force per unit magnetic field is equal to force per unit pole strength. So this is positive, the force will be repulsive force. So in this direction, in the same direction, field also will act due to this this also force will be repulsive. This is positive, so due to this field will act in this direction along this line joining. Okay, so you can say this is b2. By symmetry, whatever this angle is there, this angle also will be same. So for an equilateral triangle, this is 60 60, this is also 60, so this will be 60. To find the resultant field of these two, you have to draw a vertical line. So you can say this is making an angle, half angle with a vertical, this is also making a half angle with vertical. That means this is 60, means this is 60, this also will be 60, so this will be 30, this also will be 30. So they along this, the resultant field is, if you resolve this, you get b2 cos 30, b2 cos 30, and b2 sin 30, b2 sin 30. Similarly, due to this b1, you can say b1 cos 30 here, b1 sin 30. So B, here B1 and B2 are equal actually speaking. So B, it can also be expressed as it is equal to mu naught by 4 pi into pole strength by distance square. Pole strength is m of this source charge by distance square is a square. So B1 B2 are equal. Suppose same poles and the same at this same distances, same pole strength and at same distances a to this point. So both are equal. You can say this B1 equal to B2 equal to B equal to this. So here, so sin 30 and sin 30 is also same. So you can say B2 sin 30, B1 sin 30 are equal, directing in opposite direction. They will cancel out. They will cancel out. And here B2 cos 30 and one more term comes here, that is B1 cos 30. They will add up. So you can say net field is equal to B1 cos 30 plus B2 cos 30. As B1 equal to B2, you can say 2B1 cos 30. So cos 30 is how much? Root 3 by 2. Root 3 by 2 or 1 by 2? Root 3 by 2. 2 into B1 equal to B. That is nothing but mu naught by 4 pi into m by a square into cos 30 is root 3 by 2. So 2 cancel. So we'll get what? Mu naught by 4 pi into root 3 m by a square. Right? Yes, B net is equal to mu naught by 4 pi into root 3 m by a square is a net field at that point, right? Whereas next, I'll see the next case, second one. It is given that the question is two equal and unlike poles, each of strength m, are placed at 1 second. Magnetism. Right. Yep. So the next one is two equal and unlike poles. Unlike, you have to underline that. Two equal and unlike, two equal and unlike poles. Underline this. Unlike poles. Each of strength m. Each of strength m are placed at the two corners of are placed at the two corners of an equilateral triangle. An equilateral triangle equilateral triangle of side A of side A. The resultant magnetic induction at the third corner. The resultant resultant induction at the third corner. At the third corner is, so same way, but we have to what is the here the difference is, so equilateral triangle only, right? Hmm? Equilateral triangle, but it is given that two unlike means one should be positive pole of pole strength m, another will be negative pole of pole strength. Negative pole means south pole. I have to take this as north pole with pole strength plus m, and this will be south pole of pole strength minus m should be there. So there is a separation as a. Now what is the resultant field here, field intensity? So we have to find field resultant field at any point. You have to keep unit positive north pole. So this north pole will repel this so that this field will be along the line joining this, and this, due to this negative pole, it will be along this line but towards this. So this, so that if you draw a horizontal line here and a vertical line at this point, this is, if you say this is b1, this is b2, I can say that here also b1 equal to b2, this is equal to b is equal to v naught by 4 pi into m by a square. Magnitude of this b1 b2 are same, but by symmetry the angle, you say this is the angle made by this with the horizontal is also same. So this is 60 means this will be 60. So this is same way, the angle between this and the horizontal, this and horizontal is also 60. So this is b1, this will be b1 cos 60, this will be b1 cos 60, this will be b1 sin 60. So similarly this is b2, you say, then this will be b2 cos 60, and along this will be having b2 sin 60. So b1 b2 are equal, so b1 sin 60 b1 sin 60 b2 sin 60 cancel out, these two will add up, this will give you the net field. So net field is equal to 2 b1 cos 60, it is equal to 2 into, it is mu naught by 4 pi into m by a square into cos 60 is 1 by 2, 2 to cancel, so we get b net is equal to mu naught by 4 pi into m by a square, that is nothing but you can say rb1 rb2, right? Yes. So that is how you have to take it. The next one is third case, okay. So the magnetic induction at the center of a line joining the two poles of a horseshoe magnet of pole strength m and separated by distance a is the magnetic induction at the center of the magnetic induction at the, the center of the line, line joining two poles of two poles. You have to take this as two poles of a horseshoe magnet of a horseshoe magnet of pole strength m and separated by a distance a, and separated by a distance a is. So to understand this, we have to consider the first horseshoe magnet. Horseshoe magnet will be look like in the semicircular shape form. I am not drawing properly. You have to take this properly. Okay, like this. So let us say this is north pole and this will be south pole. Okay, so that the separation between them is, they're separated by, it is given that they are separated by a distance a at the midpoint of the line joining. Okay, you are asked to find the resultant magnetic field at the center of the line joining. Center is, let us say this is O of the line joining. What is the magnetic field? So this is north pole of pole strength, you have to take it as plus m. This is south pole, which is pole strength of this will be minus m. To find the field at any point, you have to keep unit north pole. So this will repel this. So field due to this will be this b1. Field due to this will attract this. So field due to this will be b2. So net field will be equal to b1 plus b2. So this is equal to mu naught by 4 pi into field due to this north pole is m by its distance square. This is a, this distance will be a by 2. Similarly, this also will be a by 2. So you can take this as a by 2 whole square plus this is also mu naught by 4 pi into m by a by 2 whole square. So overall you can say mu naught by 4 pi into a square by 4. 4m by a square plus 4m by a square. You can take it as 8m by a square. Hmm? So 8m by a square is the net field. So you can say 8 mu naught by 4 pi into m by s square or 8m by s square. You can simplify this. If you want to keep in mu naught by 4 pi form, you can keep as it is. Otherwise, you can say 4 ones, 4 twos, you can cancel. You can take the final value also. Depending on the options, you have to simplify it. Got it? This is briefly about this. That's it.